Airplanes weighing hundreds of tons, effortlessly soaring through the sky. It seems almost magical, doesn't it? But the science behind it is anything but. Welcome to Wing Logic, where we take complex aviation topics and explain them simply. Today, we're tackling a fundamental question. What really keeps planes in the air? Let's break down the real science of lift. I'm your host, and here at Wing Logic, our goal is to make aviation understandable for everyone. In this video, we're focusing on the core principle that allows airplanes to fly: lift. We'll cut through the complexity and explain it in a way that just makes sense. You might have encountered an explanation involving something called Bernoulli's principle. It often suggests that air flowing faster over the curved top of the wing creates lower pressure, and this pressure difference pushes the wing up. While there's a piece of the puzzle here, it's not the complete picture. The idea that air has to meet up at the back of the wing simply isn't how it always works. To truly understand lift, we need to start with the basics, the four forces of flight. There's weight, pulling the plane down due to gravity; thrust propels it forward; drag resists its motion through the air; and then there's lift, the upward force we're focused on today. For stable flight, lift must balance weight, and thrust must balance drag. The most direct way to understand lift comes from Newton's third law. For every action, there's an equal and opposite reaction. The wing of an airplane is specifically shaped and angled to do one crucial thing: push air downwards. As the wing moves through the air at a slight angle, what we call the angle of attack, it forces a large mass of air downwards, and the reaction to this downward push. The air pushes back upwards on the wing, creating the force we know as lift. It's that simple. The special shape of the wing, called an airfoil, is key to effectively deflecting air downwards. Notice the curve on the top surface, the camber. This shape helps to guide the air, and along with the angle of attack, ensures a significant amount of air is directed downwards as the wing moves forward. It's this consistent downward push that generates lift. Pilots have direct control over lift by adjusting the angle of attack. This is the angle between the wing and the incoming air. Increase the angle, and the wing pushes more air downwards, generating more lift. Decrease it, and less lift is produced. It's a fundamental control surface that allows pilots to climb, descend, and maintain level flight. Now, let's revisit the idea of pressure. Yes, the air moving over the top of the wing travels slightly faster, resulting in a lower pressure area. But this faster airflow and the resulting pressure difference are primarily because the wing is shaped and angled to deflect air downwards. It's the downward push that's the fundamental action creating lift. So, how much lift is produced? It depends on a few key things: how fast the plane is moving, airspeed; how thick the air is, air density; and the size of the wing area. These factors, along with the wing's shape and angle of attack, all work together to determine the amount of lift generated. So, there you have it. While the concept of pressure differences is often discussed, the core principle behind how airplanes stay in the air is the wing's ability to push air downwards, generating an equal and opposite upward force: lift. It's a beautiful application of basic physics, making the incredible feat of flight a reality. We hope this simple explanation of lift has helped you understand one of the fundamental principles of aviation. If you found this video helpful, please like it and subscribe to Wing Logic for more clear and concise explanations of aviation topics. Got a question or a topic you'd like us to cover next? Let us know in the comments below. Thanks for watching, and we'll see you in the next video.